Hi everyone, let's evaluate the integral I equals to integral from 0 to pi over 2 of dx over ith root of tangent x, where I is the imaginary number I squared equal to minus 1. So first of all we have ith root is 1 over I to the power of 1 over I, and tangent x is sine x over cosine x. Now if we multiply the numerator by I and the denominator by I, we get I over I squared, which is I over minus 1 and equals to minus I. So I equals to integral from 0 to pi over 2 of dx all over sine x over cosine x all to power minus I. Now we can put this whole term in the numerator, and instead of power minus I, we will put to the power I, because 1 over a power minus n equals to a to the power n. And so I equals to integral from 0 to pi over 2 of sine x over cosine x all to power I and dx. Now we can distribute the power I over the numerator and the denominator to get sine power I of x over cosine power I of x. And 1 over cosine power I of x can be written as cosine power minus I of x. And so I becomes integral from 0 to pi over 2 of sine power I of x multiplied by cosine power minus I of x. This term looks like the beta function, where beta mn equals to 2 integral from 0 to pi over 2 of sine power 2n minus 1 x multiplied by cosine power 2n minus 1 of x dx. So let's make the power in the form of 2n minus 1 and 2n minus 1. Here I can be written as 2 multiplied by 1 plus I over 2 all minus 1. So here we have 2 over 2 will cancel out, and 1 minus I minus 1 is I. Similarly, for the term minus I, it can be written as 2 and multiplied by 1 minus I over 2 minus 1. And so I now is in the form integral from 0 to pi over 2 sine power 2n minus 1 of x multiplied by cosine power 2n minus 1 of x dx. Now we have to make this 2. So I can be written as half multiplied by 2 and multiplied by this whole term. So now we have I equals to half all multiplied by this term looks like the gamma function or the beta function, where m equals to 1 plus I over 2 and n looks like to 1 minus I over 2. And so I will be half multiplied by beta mn, which is beta. M is 1 plus I over 2 and n is 1 minus I over 2. Remark that beta equals to, beta mn equals to gamma of m multiplied by gamma of n all over gamma of m plus n. And so I becomes half multiplied by gamma of m is gamma of 1 plus I over 2. Gamma of n is gamma of 1 minus I over 2. All over gamma of m plus n is gamma of 1 plus I over 2 plus 1 minus I over 2. Here we have half plus I over 2 and half minus I over 2. So I over 2 and minus I over 2 can be cancelled out. So we get gamma of half plus half, which is gamma of 1, and gamma of 1 equals to 1. And so we can write I equals to half multiplied by this term, which is gamma of 1 plus I over 2, multiplied by gamma of 1 minus I over 2. But 1 minus I over 2 is the conjugate of 1 plus I over 2. So I can be written as half gamma of 1 plus I over 2 multiplied by gamma of 1 plus I over 2 bar. But we can write gamma of z bar equals to gamma of z all bar. And so I equals half gamma of 1 plus I over 2 multiplied by the conjugate of gamma of 1 plus I over 2. Recall that z multiplied by z bar equals to modulus of z all squared. And so we can write I as half multiplied by modulus of this term all squared, which is modulus of gamma of 1 plus I over 2 all squared, equals to half multiplied by modulus of gamma of half plus half I all squared. Recall that we have this formula, modulus of gamma of half plus ik all squared equals to pi over cosine hyperbolic of k pi, with k equals to 1 over 2. And so I can be written as half, here we have half, multiplied by this term, which is pi over cosine hyperbolic of k pi, which is pi over cosine hyperbolic of half pi, which is pi over 2. And so I equals to, here we have half by pi is pi over 2, and here we have cosine hyperbolic of pi over 2. Therefore, we have I equals to integral from 0 to pi over 2 of dx over ith root of tangent x equals to pi over 2 all over hyperbolic cosine of pi over 2. That's all for now. Thank you for watching.